Welcome to video 3. Our objective today is to identify a convergent geometric series and find the sum of a geometric series. Please follow along in your notes. An infinite sequence is a list of numbers that continue for infinity. An infinite series is the sum of the sequence. Please note the difference between the two. If A sub n is an infinite sequence, then the summation of those become the series. As I said in the last video, please, we do a lot with the nth term. So you want to make sure you understand what the nth term is. Now in this video, we're going to talk about partial sums. However, in our class, we do not deal with partial sums. So I want to give you an example of what we're doing in a geometric series. If we start with a half, each time we divide that by 2, we get smaller and smaller. Adding all of those together is an example of an infinite series. We would say that this series converges because it approaches a limiting value. Please take this in your notes. In a geometric series, each term is found by multiplying by a common ratio called r. R is important because we say that it converges if r, the absolute value of r, is less than 1. And the sum is a over 1 minus r. Both of those are very important terms. If the absolute value of r is greater than 1, then a series diverges. In the next unit, we talk a lot about the interval of convergence, but the interval of convergence would be from -1 is less than r is less than 1. This is not in your notes, so just watch. In this example, if we continue to add these up, we would get 1/3 because our initial term a is 3/10. Our r is 1/10. So using the formula that I just gave you, we see that the sum is 1/3. This is another example. It's not in your notes, so just watch. This one, the initial term is 1. R is -1/2. Notice that it's alternating. But it converges to 2/3. This is a big idea in this class. A geometric series with ratio r diverges if the absolute value of r is greater than 1. It diverges if the absolute value is greater than 1. It converges if the absolute value is between 0 and 1. And it converges to the sum of a over 1 minus r. Please notice the format because that format becomes very important in recognizing whether or not it's a geometric series. So once again, here's the big idea. We want to look for the form a times r to the n, and we're summing from n equals 0 to infinity. If that's the case, the sum then is a over 1 minus r. It converges when the absolute value of r is less than 1. It diverges when the absolute value of r is greater than 1. That's our big idea, and we must understand that. Please star this, highlight it, do whatever you need to do to remember this. All right, let's do some examples. The first thing we have to recognize is what is the value of r to determine whether or not it converges or diverges. What is the value of r? And what is the value of a? So in this first example, r is equal to whatever this is. So r is equal to 4/3. Will this converge or diverge? Well, this would diverge. Why? Because the absolute value of r is greater than 1. 4/3 is greater than 1, so this would diverge, and we're done. In our next example, we have to look at this carefully. We could write this as 4 times 1 over 2 raised to the nth power. Okay? And once we write it like this, we see that our absolute value of r is less than 1, so therefore this converges. Now the question becomes, what does it converge to? So to find the sum is equal to a over 1 minus r. A is not necessarily 4. A is whatever our first term is, and to determine our first term, we have to make n equal to 1. So when I make n equal to 1, I get 4 times 1/2 raised to the first power, which is 2. So in this case, A is equal to 2. R we found from here was 1/2. So I get 2 over 1/2. This sums to 4. Okay? So coming down here, once again, we have to find the value of r. R is equal to negative 2/3. We can sort of easily see that one. R is equal to negative 2/3. A, however, we have to figure out what A is. Once again, to figure out A, I have to substitute in 3 in for n. So I get 2 negative 2/3 raised to the third power. That'll give me 2. Negative 2 cubed is negative 8 over 27. So A is negative 16 over 27. So to find the sum, it would be negative 16 over 27, 1 minus negative 2/3. Okay? And I'll let you figure that out. Let's do the last 3. Okay, so we have to rewrite this. So we're going to have to use some algebra to rewrite this. So we can write this as 3, 2 to the n times 2 to the negative 1. Now please, we've done this before, so please recall that. So to find out r, all of this is considered a constant. So I have 3 times 2 to the negative 1. That'll come up to the top. So that would give me, I could actually write this as 6 over 2 to the n. Or I could write it as 6 times 1 over 2 to the nth power, which makes my r 1/2. My value of A, I plug in n for 0. When I plug in 0 for n, that makes this 1, so A is equal to 6. So I have 6 over 1 minus 1/2, which is 12. Okay? For this problem, I can write this as 1 over 100 times 2 to the nth power. So in this case, A is 1 over 100. If I plug in 0 for n, I get 1, so I get 1 over 100. R is equal to 2 to the nth power. If r is equal to 2 to the nth, it's less than 1, so it's greater than 1, so it diverges. And actually, I should say r is equal to not 2 to the nth, but r is equal to 2. Sorry. This one, what I didn't say here, this would converge because r was less than 1. This would diverge because r is greater than 1. Finally, looking at this problem, once again, we're going to have to do some algebra to this problem. We get 4 to the nth times 4 squared over 5 to the nth times 5 to the negative 1. Now, my value of r, I can rewrite this using algebra. I can write this as 4/5 to the nth power times 16 times 5, which is 80, right? So in this case, when n is equal to 2, my initial condition is going to be 80 times 16 over 25. And r is equal to 4 over 5. So we know this converges because r is less than 1. The absolute value of r is less than 1. We know that converges. Just what does it converge to is the question. So that's some big number that I really don't feel like doing. This is going to give me, actually, 5 goes into this 6 times. 5 goes into this 5 times. So it's 256 over 5. Okay, so the sum would be 256 over 5 over 1 minus 4/5, which is actually not that bad because that gives me 256 over 5 divided by a fifth, and the 5s would cancel out, and I think that's 256. But if my math is wrong, then my process is right. My math may be wrong. Okay, so let's just recap quickly. A sequence is a list of terms. A sequence will converge if its limit is finite. A series is a sum of a sequence, and a geometric series will converge when the absolute value of r is less than 1. George Washington Carver is our spotlight today. I love this saying, 99% of failures come from people who have the habit of making excuses. Of course, as a teacher, I love that saying. George Washington Carver did a lot with the peanut. So if you enjoy peanut butter, you should thank George Washington Carver. Your homework, your classwork for tomorrow is going to be in your book and then page 3 of your notes. Have a great afternoon.